Once again, my name is Victor here, and in this class, we are looking at another problem that has to do with a circle and a triangle. A circle this time inscribed in a triangle. We have, looked at several questions and problems already. Still on circle, and its properties. And then this is one of it. It's a WAEC examinable question I also got, and this question is asking us to calculate the area of the shaded part. It's asking us to calculate the area of the shaded part. By description, they are telling us that this WXYZ is a semicircle with center O. So this place is the center of the semicircle. Okay, that it is inscribed in an isosceles triangle ABC. If this is equals to this, that is AC is equals to BC. That's what makes it isosceles, of course. And then OC is 30 cm. That's from center here to this point is 30 cm. And this angle here is 130 degrees. Calculate to the nearest whole number area of the shaded part. Area of the shaded part. Area of the shaded part. This is a semicircle that is inscribed in area of the shaded part. Is it? Oh, I omitted something. The first question there is calculate the radius of the circle. I think says I omitted it. Calculate the radius of the circle, and then the second, which is B here, is now calculate to the nearest whole number the area of the shaded part. Okay, so now if we want to calculate the first one that says the radius of the circle, how can one be able to do that? Okay, there are some things I'm going to bring up here, which in subsequent classes I am still going to show their proof. That is a theorem that says the angle or a line drawn from the center of the circle, which is perpendicular to a tangent to a circle, is at right angle to it. Let me take it again. A line drawn from the center of the circle. Of course, whenever you hear a line drawn from the center of the circle, once it touches the circumference, it becomes the radius. But if there is a tangent, what is a tangent? A tangent is something like this AC that strikes this circumference at a point, like this BC that strikes this circumference at this point Y. So if there is any line coming from this center of this circle, though a semicircle, but this is a circle, this center is here. Once there is a line coming from this center and is coming down to this point, and it touches this tangent to this circle at a point, they say that that theorem says that which is perpendicular to that tangent, that theorem says that that line is at a right angle to that tangent, meaning that the angle formed between that line and the tangent to the circle is 90 degrees. I'm sure you understood that. Is 90 degrees. So that is what exactly is going to help me to be able to explain or to calculate the radius, which is the first question there. All right. So if I make a marking here, and it lands at this point, you can see an extraction here. Okay, you can see that something is formed here. But before then, there's something I also want us to take a look at here. That thing is this, that this line is equal to this line. It is described in the question. This line is equal to this line. And did you realize that OC is common to this triangle and this triangle? Where am I dragging us to? The similarity between this triangle and this triangle. This line is equal to this line. And this line is common to this and this. And for the fact that is true, it then means that this angle here will be equal to this angle here. And this line AO will also be equal to this line BO. We are going to do this explanation I'm giving now. I'm going to do it as a proof when I'll be looking at chord properties. I will do that proof. But here I'm going to borrow it. Okay. So it then means that if I extract this now, if I extract this, look at what we are going to have. This is O, this is Y, this is 30 cm, and this will be half of 130 degrees, which is 65 degrees. By that explanation I gave, the first explanation I gave is that any line drawn from the center of the circle which is perpendicular to a tangent to a circle is at right angle to it. That is why here is 90 degrees. It's a theorem and it has a proof, which we are going to do later. Then, by similarity of this triangle and this triangle, we say that here is equals to here. That's what they described in the question. And this line OC is common to this and this. It then means by that this is equal to here, and this AO is equal to BO, and this angle here will be equal to this angle here. It then means that this line OC divides this 130 degrees into 2. This angle here will be 65 degrees. If that is the case, here can be called the radius because it touches the center and the circumference. And we can by this now calculate the value of that radius. I'm trusting God you understood that. Let's take it. We can now use the concept of what we call SOHCAHTOA. Okay, this is opposite and this is hypotenuse, and that is the ratio of opposite to this hypotenuse side is sine of this angle. So we are going to say sine 65 is equals to opposite, which is OY, all over hypotenuse, which is this is C, OC. So this will give us sine 65 equals to OY, which is R, over OC, which is 30 cm. So when we come over here, we are going to cross multiply, and we obtain that R is equals to 30 sine 65, and then let's see what that gives us in my calculation. So sine 65, this is 30 times sine 65 is 0 0.90631 9063. Okay, the product of both is R equals to 27.2 cm. So this is the radius of the circle, not the circle. Yeah, this is the radius of the circle as required in the first question. Okay. The next thing now is how do we calculate this question that says calculate to the nearest whole number area of the shaded part? If you look at what is happening there, we have a semicircle and we have a triangle. So look at the way I am going to explain it. I am going to say area of the shaded part is area, because this semicircle is inscribed inside the triangle, so the triangle should be bigger. So area of the triangle minus area of the semicircle. That's what it will be. Okay. Now let's start with area of the triangle. Area of triangle ABC will be equals to half base times height. But you check out that this base AB is not known, but so that base B is equals to AB. Okay, so B is equals to AB, but we don't know AB, but we can do something, because this AB is equals to 2 times AO. Can you see that here? AO, 2 times that. Okay, so it then means we can start from calculating AO. So from AO, we can have something like this. Remember, here is 30, not 30. This side is 30 cm, and here is 65 degrees. Okay? Yeah, this is A, this is O, and this is C. You can see it from that diagram. Now, if you watch here, this AO now is opposite to this angle, and this is adjacent to it. So I am going to deploy this concept of ratio of the opposite side and the adjacent side, which is tan of this angle. So I will say tan 65, which is equals to AO. I'm just trying to position this in a way that you will not be out of your view. AO over opposite over adjacent, which is OC. Okay, so this will be tan 65 equals to AO over 30. So it then means that AO is equals to 30 tan 65. Okay, so AO, which is equals to 30 tan 65 is let me figure out what it is in the figures I have here. Tan 65 is 2.1445. So I have 30 times 2.1445. So 30 times that will give us 64.3. So AO is equals to 64.3 cm. It then means the base of the angle AB will be equals to 2 times 64.3, which is equals to 2 times that will give us 128.67. 128.67. Okay, so this is the base of the angle of the triangle, and with this now we can calculate the area of the triangle, half base times height. Therefore, area is 1 over 2 base, 1 over 2 times 128.67 or 7, then times 30. Okay, so that will give us what? Let me look at the figures I have ready so I don't take time. Okay, that will give us 1930.1 cm squared. So 30.1 cm squared. That's the area of the triangle. Okay. What about area of the semicircle? Now say also area of semicircle. Look at how I'm going to put it. It will be 1/2 because we are talking about half of a circle here. 1/2 pi r squared. Please, I'm sure you understood that. And that will give me, that will be 1/2 times 22/7, then times the radius we have calculated previously is 27.2. So I will have 27.2 all squared. Okay. So that means 1/2 times, let me take away 2 here, take away here, I have 11. So I now have 11 times 27.2 squared all over 7, and that will give me from the figure I have here already 1162.6. okay, cm squared. That's the area of the semicircle. Okay, we can now bring into conclusion, therefore area of the shaded part will now be area of the triangle. Okay, area of the triangle, which is 1930.1 minus area of the semicircle, which is 1162.6, and our final result will be 767.5 cm squared. Let me come out so that you can see that. Look at it again. Look at it. So what are the steps that we followed in handling this problem? What are the steps we followed in taking care of this? Remember, I was able to explain to you that any line drawn from the center of the circle, which is perpendicular to a tangent, is at right angle to it. So that helped me to be able to extract here this triangle to be right angled here, and because of that I was able to, now similarity of this triangle and this triangle helped us to know that since this line is equal to this line and this OC is common to both these sides, that means AO will be equal to OB. It has a theorem. Okay, and then it then means that this angle here, okay, will be half of it will be here and half of it will be here. Okay, and then we have this, and we are able to solve and obtain the value for the radius. Okay, and that is 27.2 cm. Please look at the watch the video again and again so that you can be able to understand all these details. It's enormous, but I'm trusting God that you will get it right and you will understand it. It's not too difficult to understand. Please take it step by step. Look at the procedures I give step by step so that you can be able to understand it. Please and please. Okay, this is a WAEC examinable question like I told you earlier. Please share this video to someone, like our video, and click on the subscription button so that you can be able to access all the classes we have had already. From there, you can be able to begin to follow us and understand these ones that are looking a little bit complex. You are going to see the kind of problem I'm going to solve in the next class. It will be stronger than this one. Yes, I bring those classes so that we don't try to sympathize with anything, because we don't know the nature of the question you will be facing out there. That's why we bring it, the most difficult ones here. Okay, we will keep on bringing problems and be solving them here. If you subscribe to our channel, you click on the notification button, you will be able to know when we make uploads. Please like our video and share it to someone out there. And as you do that, God will bless you.